Hello guys, how are you doing? Welcome to our mathematics class. So this time we are talking about lowest common multiples and highest common factor using prime factorization. So we're discussing about the meaning of the two things mentioned above. So in our learning outcomes, we have understanding how to find LCM and HCF by listing out the multiples and factors. It means at the end of the class, we're able to understand that, and also you're able to understand how to use prime factorization to find LCM and HCF. So that leads us to the keywords. So in our keywords, we have the meaning of LCM and HCF. So what does that mean? The LCM stand for the lowest common multiples of two numbers, while the HCF stands for the highest common factors of two numbers. So moving forward, before we get to this is the lowest common multiples of number. So example is given to us, find the LCM of 12 and 16. But one thing you must understand basically before we move to this particular example is to understand what common multiples means. So your common multiples, starting from the multiples of number, just like you have your multiplication table, when you increase number by a certain number, for example, if you want to increase your 2, using your multiplication table, it increases by 2. That is, you have 2, 4, 6, 8, 10, 12, 14, 16, 18, and the rest. So the same thing applies to other numbers as well. So if I mention the multiples of 3, you can see 3 increases by certain numbers as well, just the way you have it in your multiplication table. So we have 3, 6, 9, 12, 16, sorry, 15, 18, 21, 24, and the rest. So the same thing applies to other numbers, just as number increases. So moving to our examples, we have find the lowest common multiples of 12 and 16. So all you have to do first, don't forget this method right here is called multiple method. So all you have to do first is to find the multiples of 12, find the multiples of 16. So doing that, after writing your multiple, just like what we have here. So the multiples of 12, we have your 12, we have 24, we have 36, we have 48, we have 60. So you can see 12 is increasing, just like you have it also in your 16. So we have 16, 32, 48, 64, 80. So having gotten the multiples of the two numbers, all you have to do next is to look for the numbers that are similar or you can think is common to both sides. So what are the two numbers you can see from both ends? So let's check from 12. Okay, there is 12 here, not 12. We have 24. 24 is not here. So what are the numbers that are identical here or common? Okay, I think we have 48. So from the multiples of 1 to 10, I think we have only 48 that are similar or that are common to both sides. So all you have to do is put down your 48 as the common multiple. And if you notice, 48 is the common multiple here, but you still have more. If you extend the multiples of number, you can still have more numbers that are common. But being the lowest and being the only common multiple, you just write it down as your common multiple. And don't forget what I told you about your L. Your L means the lowest or the least or the smallest. So it means 48 remains the smallest common multiple, just as we have it as the only one. So that make your LCM to be 48. Don't forget this is still multiple method. All right, moving forward, we have other examples. We have 12 and 16. We have done this. And we can now move to prime factorization. So, like I mentioned the other time, the one we solved earlier was multiples. So, in your prime factorization, it can be used to find LCM of large numbers. So, just follow the steps. So, if I ask you to find the LCM of 128 and 60, you may not be able to find the multiples of 128. That's be very too much for you. So all you have to do is use your prime factorization. So how do you do that? it involves steps. So the first step, so write each number as a product of its prime factors first. The other one is you place the prime factors of both numbers in a Venn diagram. If you don't want to use Venn diagram, you can use your table method or other forms you think you have seen. The other one is okay, you cannot calculate your LCM and HCM from the Venn diagram. So I believe the Venn diagram is not that common. So let's see how it works. So finding the LCM of 16 and 84, just like I mentioned earlier, 16 and 84 using multiple method can be very exhausting. It can drain you because if you start looking for multiples of 60 alone, that can take chunks of your time. So let's use our prime factors. So using prime factor is very easy. So start with 60. So all you have to do is you have your 60. If you have your 60, what do you have? That is 30. That is splitted. That is, if you divide it by 2, that make it 30. So you have your 2 here and you have your 30 beside. If you have gotten your 30, you can still have it again. You move it further. So how do you have it? Divide by 2 again. So 2, then 30. So 2 in 30, that will be 15 times. You write your 15 under here. And in your 15, you may not be able to add 15, but don't forget 15 is divisible. So what is the number that can divide 15 without remainder? The least number. So it should be, if you say 2, well, it may not be divisible, but 3 can actually do that job. So let's use 3. 3 and 15, that should be 5. So that's how you have your 5 here. We can now move to 84. That is for 60. We can now move to 84. So let's have 84 first. Which number can divide 84 with the lowest number? So we can use 2. So 2 can divide 84. How many times? Okay, we have 42 here. All right. So also we can divide 42 by least number again. So what this number can divide 42, we can use 2. So 2 in 42 will give us 21. And here we may not be able to use 2 again because here we have odd number. So what can we use? Think of a number to use that can divide 21 without remainder. So the least number that can divide that should be 3. So 3 in 21, that would be 7 times. So what's the next step after this? Now, we can use our Venn diagram to do that now. So if you notice from the initial one, we have something is common to both sides. So what are the numbers common to both sides? The number common to both sides should be at the middle of your Venn diagram. So 2 is common to the two numbers. So you can have 2, 2. What number is common again? I think 3 is also common. So all the common numbers should be at the middle of your Venn diagram. And the numbers that are not common, that belongs to either the two numbers, should be in their diagram. So that's why we have 5 in 60 here and we have 7 in 84. So let's go to the next step. All right. So that is that for 16 and 84. So easily can use a Venn diagram to calculate your LCM without using multiple method. So because like I mentioned, there are many methods can still use to solve your HCF, but this Venn diagram I believe is one of the easiest if you ask me. All right, so let's go to other ones. How to calculate LCM and HCF from the Venn diagram. So we can use our LCM. So just find the numbers together. That is, find all the numbers, calculate, multiply all the numbers that are common, and you can find the two numbers. What are the numbers you can find the two numbers? So 2 is there, 2 is also there, 3 is there, 5 is there, 7 is there. So multiply it together. So 2 times 2 will give you 4, times 3 times 5 times 7 all will give you 48. So HCF, so don't forget the HCF is the highest common factor. So it has to be only the number at the middle of your Venn diagram, not all the numbers together. So that is what differentiates LCM and HCF. So the HCF will now be 2 times 2 times 3. That will give us 12. So that is the HCF of 16 and 84, while the LCM remains 480, 483. And also, for me to be sure you understand this, let's see what you can do using your Venn diagram. So, your turn, find the LCM of an ACF of 24 and 30 using Venn diagram. Let's see what you can do. All right, so here is my solution. So using the Venn diagram is very easy and straightforward. All you have to do is to table it, then insert all your numbers inside your Venn diagram, that's inside the circle. So the identical numbers you can see in 24 and 30 should be at the middle of the Venn diagram, while the numbers that are not really identical should be beside the two numbers in different circle. So let's find the LCM of the two numbers. So don't forget, finding the LCM means you have to multiply all the numbers together. So we have 2 times 2 times 3 times 5 times 7, which will give us 420. And the HCF should be the only number at the middle of your Venn diagram. What are the numbers? You have 2 times 2 times 3. That gives us 12. So we have any question you want to ask me? All right. The question. Thanks for your time. I believe you understand how to calculate your LCM and HCF using Venn diagram of prime factorization. All right. Thank you for your time. See you next class.